Hello everyone, I welcome you all to my online classes. This is Om Maths Corner. Today we shall discuss the questions of the exercise 14.2. The name of the chapter is Symmetry for the students of class 7. So before proceeding towards the questions of the exercise, let us have the introduction. Here we shall discuss rotational symmetry. In this exercise, the topic is rotational symmetry. Dear students, observe this clock carefully. What you see? What do you say when the hands of a clock go round? You say that they rotate. The hands of a clock rotate in only one direction. Okay, this is the second hand, this is the minute hand, and this hand is called hour hand. Once again, this is rotating, this is second hand, this long hand is called minute hand, this small hand is called hour hand. Okay, they are rotating in particular direction, same direction. Okay, after 1 this is coming to 2, after that this is coming towards 3, then it will come towards 4, 5, 6, 7, 8, 9. Every time this rotate this way. Okay, the hands of a clock rotate in only one direction about a fixed point. This point is called fixed point. This is called the center of the clock face. Rotation like movement of the hands of a clock is called a clockwise rotation. Okay, otherwise it is called anti-clockwise. So what is clockwise rotation? If rotation is like this, anti-clockwise mean otherwise. Now observe this ceiling fan carefully. What you see? The blades of the ceiling fan, they are also rotating. What is the rotation? Is this clockwise or anti-clockwise? My dear students, the rotation of this ceiling fan is anti-clockwise, because clockwise mean this way rotation, whereas we saw that the ceiling fan was rotating this way, anti-clockwise. Now what you say about the wheels when they spin? Okay, are they rotating clockwise or anti-clockwise? Clockwise or anti-clockwise? We see that wheels of this bicycle can rotate in either ways, clockwise as well as anti-clockwise. This way we have seen that when an object rotates, its shape and size do not change. The rotation turns an object about a fixed point. This fixed point is called the center of rotation. For example, this is the clock. Okay, this point where all the three hands they are fixed, this point is called center of rotation. What is the center of rotation of this hands of a clock? This is the center of the rotation. Okay, now we shall discuss about the angle. The angle of turning duration rotation is called angle of rotation. A full turn, you know, means a rotation of 360 degree. Okay, from 12 after rotating full circle. This is called rotation of 360 degree, right? 360 degree mean one complete circle, 360 degree, right? Now half circle, this rotation is called half of 360 degree, that is equal to 180 degree. This is called half. Okay, from here to here, one straight line makes an angle 180 degree. Now again making the half up to here, from 12 to 3, mean to say again half of 180 degree, that is equal to 90 degree. So from here to here, this is called 90 degree, right? So we have seen that if rotation is like this is rotation is called clockwise rotation, right? And this rotation is called anti-clockwise rotation, right? This rotation is called like the rotation of the clock, hands of the clock. This rotation is called clockwise, and opposite rotation is called anti-clockwise rotation. Have you ever made a paper windmill? This is the paper windmill. The paper windmill in the picture books looks symmetrical. Okay, four feathers of this paper windmill, they are symmetrical, but you do not find any line of symmetry. No folding can help you to have coincident halves. However, if you rotate it by 90 degree about the fixed point, the windmill will look exactly the same. We say that the windmill has a rotational symmetry. These pictures, look these pictures carefully. A, B, C, D. After rotation, 90 degree rotation, when this A reaches here, even the shape do not change. Shape of the diagram remains same. When this A again reaches now here, 90 degree rotation, then the shape is same, just only A, B, C, D they are changing. Again this D reaches here. Okay, lastly A comes back at its original position. So 90 plus 90 plus 90 plus 90, 360 degree. Okay, it means 90 degree is the angle of rotation which gives the diagram looks same. In a full turn, there are precisely 4 positions on rotation through the angle 90 degree, 180 degree, then 270 degree, lastly 360 degree, when the windmill looks exactly the same. Because of this, we say it has a rotational symmetry of order 4. It has a rotational symmetry of order 4. Here is one more example for rotational symmetry. Consider a square with P as one of its corners. This is one corner P. Okay, when this P reaches here, what happens? 90-degree clockwise rotation. In third diagram, P reaches here. Again 90-degree. Lastly, fourth time P reaches here. Right? Fifth time this is again at its original position. So 90 plus 90 plus 90 plus 90, 360-degree. So again we say that this diagram has a rotational symmetry of order 4, because after rotating 4 times 360-degree, 4 times this looks same. If P is not there, then the shape of the diagram, there is no change. So this rotation is called a rotational symmetry of order 4. Thus, a square has a rotational symmetry of order 4 about its center. Observe that in this case, number 1, the center of rotation is the center of the square. The angle of rotation is 90-degree. The direction of rotation is clockwise. The order of rotational symmetry is 4. So these are the 4 things we have to observe carefully. Now look at this picture, these diagrams. 120-degree, 120-degree, 120-degree. Can you now tell the order of rotational symmetry for an equilateral triangle? Yes, 3 is the order, because 3 times when this corner reaches here, after that here, see here, R is here, second time this is at here, third time this is at here, fourth time it takes the same position. So what is the order? 1, 2, 3. 3 is the order of rotational symmetry of an equilateral triangle. Right? Now second, which of the following shapes have rotational symmetry about marked point? This is the marked point. Okay? See the diagram. I have drawn this on this paper. What we see? If I rotate this, I am writing here P. When P is at here, I have prepared one more example, one more diagram. When this rotate 90-degree angle, okay, P is now here. Are both the pictures same? No, there is a difference. Again now what happens? This moves. P reaches downward. Are these two diagrams same? Yes, they are same. So what happens? What is the order of this rotation? Order of this rotation is 2. First of all, the center of rotation is the center of square. Here, this is the center of rotation in this diagram. Second, the angle of rotation. Angle of rotation in this diagram is 180-degree. Third thing, the direction of rotation is clockwise. We were rotating this way. Okay, so this rotation was clockwise. The order of rotational symmetry is 4 in case of square. But here in this diagram, the order of rotational symmetry is 2. Because when this P is here, first time we rotated this P up to here. Okay, this is one order. But again we rotate this second time, 2 times. Then P reaches at the same place. Okay, so this is why we say what is the order? Order of rotation is 2 in this diagram. Similarly, what you say about the order of this cross? Third is B and this star shape 1, 2, 3, 4, 5. So 5 will be the order of symmetry in this fourth case. Okay, 5. What is the angle? 360 degree divide 5. Okay, this way we can also find the angle of rotation, because 5 is the order of rotational symmetry. One very interesting thing is every object has a rotational symmetry of order 1. This is 100% sure that rotational symmetry of order 1 is everywhere true for every object, as it occupies same position after a rotation of 360 degree, that is one complete revolution. Such cases have no interest for us. Okay, now what is the interest? You have around many shapes which possess rotational symmetry. For example, this fruit, what is the name of this fruit? Yes, this is orange, right? Let us see what happens when we cut this. We are going to cut this into two halves, two equal halves. Okay, this way. Now what we see, how many slices are there starting from this one? Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13. So 13 slices are here, right? So what is the order of rotation in this case? 360 degree divide 13 is the angle of rotation. Okay, that mean what is the order of rotational symmetry? 13. 13 is the, this is the seed. If one time 13 times rotation, 13 times this looks same. Okay, after rotating 13 times this way, lastly it occupies the same place. Okay, now what you say about this road sign? What is the order of rotational symmetry? Of course, the order of rotational symmetry is 4. Now this is the wheel. What is the order of this rotational symmetry of this wheel? Starting from this point, 1 2 3 4 5 6 7 8 9. Once again, this is the wheel, rotational symmetry. What is the order? Starting from this point, 1 2 3 4 5 6 7 8 9. So 9 is the order of rotational symmetry of this wheel in this diagram, right? Now we come to the questions of the exercise. Which of the following figures have rotational symmetry of order more than 1? It has rotational symmetry of order 4. This is the equilateral triangle, so it has rotational symmetry of order 3. Now look at this picture. I have the diagram of this picture as well. So what is the order? First time I rotate this, no, this is not looking same, because the mouth of this, it is turning back side. So again we have to rotate. Mean to say its order of rotational symmetry is 1. So this is not the answer. C part, we have to find the figures which have rotational symmetry of order more than 1. So it has rotational symmetry of order 4, okay, 3 is okay, 1 not okay. Now what about this D? In D part, what happens? This is the diagram. If 90-degree rotation, the diagram is not same. 180-degree rotation, yes, diagram looks same. So what is the order? Here order is 2. In C part order is 1. In this diagram circle, of course the order is 3. Here the order is 4. So which of the following figures have rotational symmetry of order more than 1? This has order more than 1, 2, 3, 4, 5. Okay, this is the answer. Now we come to question number 2. Give the order of rotational symmetry for each figure. This is the A part. In A part, what we see, like this, we have the diagram. Okay, this is the diagram. So if we rotate this at 180 degree, the same shape becomes there. So 180 degree mean 2 times. What is the angle order of rotational symmetry? Order is 2. Here 80 degree, 80 degree, this is the diagram. So this is vertically opposite angle, this is also 80 degree. Okay, if I rotate this way, same shape is formed. So what we say, at rotating about with an angle of 180 degree, same shape is found. So order of rotational symmetry is 2. In this equilateral triangle, order of rotational symmetry is 3. This is the windmill, paper windmill, 4 equal blades. So what is order of rotational symmetry? 4. Now this part, E part, here order is 4. This is the pentagon, 5 equal regular pentagon. So what is the order of rotational symmetry? 5. This is the star, 1, 2, starting from here, 1, 2, 3, 4, 5, 6. So 6 is the order of rotational symmetry. Now H part, here 3 is the order of rotational symmetry. So this was our exercise for